Hey everyone, it's Ramon here, and today I just wanted to do something a little different from my regular tutorials. Today I want to play a little bit with the probabilities of the outcomes when one is actually rolling the dice. So I built everything in Excel here, and the reason why I'm doing this is kind of embarrassing actually. I went to a friend's house the other day, and a great friend of mine, Phil, and he introduced me to the game The Settlers of Catan. And we used two dice to play the game, and he asked me the question, do you know which number is the most probable number that one can get on rolling two fair six-sided dice? And I had to think about it. I didn't know by the top of my head, which is the reason why I got a little bit embarrassed. But right away I kind of left the game and I asked him for his computer, and I pull up Excel and I worked on the probabilities of all of the potential outcomes when rolling the dice. So I built this in Excel. I wanted to show you how it's done. It's very simple actually, and also very intuitive. So what I have here on column A is, say, die number 1 or the first die. I have all of the sides laid out here. So I have 6 1s, 6 2s, 6 3s, because obviously I have a six-sided die, and then 4s, 5s, and 6s, as you can see here. For my second die, I simply laid out the sequence between 1 and 6, 1 and 6, 1 and 6. That way, I can simply compute the outcomes here by summing them up. So I can just say, well, if I roll the dice and the first one is 1, and the second one shows also 1, my outcome will be 2 in this case. And if I apply that same function there for everything else, I can see that I have 36 possible outcomes. So that's because we have 2 dice and each die has 6 sides, so 6 times 6 is 36. But I can also see the outcomes themselves. So for example, if I roll the dice and the first die shows me a 3 and the second die shows me a 2, my outcome is 5. Similarly, if I have another row, another throw, and I see, say, on the first die the number 6, and then on the second die the number 1, my outcome is 7. So it's a very simple way of just showing all of the potential outcomes that one can have or one can see when rolling two fair six-sided dice. So with that out of the way, let's look at the probabilities. Let me drag this out here. There we go, those are my dice. The question is, first and foremost, what are the potential outcomes? Now, I laid out here all potential outcomes, but you can see that some of them are a repeat. For example, I can get the outcome 4 by throwing the dice and having a 1 and a 3, but I can also see a 2 and a 2. I can see a 3 and a 1. So those are the potential outcomes. It can only be between 2 and 12. Think about it. When you throw the dice, the bare minimum result or outcome that you can see is 2, because you have 2 dice, each one with the number 1 showing. And the highest number, the highest outcome, or the highest combination that you can have is 12. That's because each die in this case will have the number 6 as a result. So together, if you sum them up, is 12. So that's the intuitive part of this. You can think about it, and if you kind of picture that in your head when you're throwing the dice, you can think about it and say, what is the bare minimum that I can get? The minimum possible number I can get? Well, it has to be a 2, because the lowest number that I have on the side of the dice is number 1 for 2 dice, and then 1 plus 1, 2. And the maximum that you can have is 12, because you can only get 6 and 6, 12. You cannot get any number over 12 or under 2. So those are the possible outcomes. Now, the next thing that I did here to compute the probabilities is just to count how many times each one of these outcomes actually will occur or is probable to occur, given that roll of the two fair six-sided dice. So I use the function countif in Excel very simply, just saying go in there, go into the range equals countif C2 to C37, as you can see here. And if you see that outcome 2, count how many times that occurs. So applying the function here, as I just explained intuitively as well, you can have only one potential, one possible outcome for 2, and also one possible outcome for 12. There's no other way to get those two numbers more than that one occurrence. There's only one way you can get the result 2, and only one way to get the result 12. For the other outcomes, however, it's a bit different. It starts to grow to that center that we're going to talk about in a bit, number 7, and then it starts to decrease symmetrically from that middle point to both ends. For number 5, for example, I have 4 different combinations that I can see the result 5. And if I simply filter the data here, just as a double check, let's look into the outcome 5. And I can see the 4 ways of which I can get the outcome 5. I can have 1 and 4, 2 and 3, 3 and 2, 4 and 1. So that's correct. Let me just go back to my entire list here. And the last thing that I did was just to calculate the percentages, or in this case, the probabilities of those outcomes occurring. So if you simply divide this count, for example, I have 1 out of 36, so that's 2.8%. You can see my formula here as well. 1 divided by, all the way down here, 36, or even this number here, doesn't matter, it's the same. And if I go, for example, for, say, possible outcome 8, I have 5 possible combinations, and if I divide that number by the total outcomes that I can have, which is 36, I have that 13.9%. And as you can see, 7 is actually the answer to my friend's question. What is the number that is the most likely number to come out as a result of throwing 2 dice? Is number 7. There's a 16.7% chance that you'll see a 7. And that's simply because I have more ways, more combinations to see that result. I have 6 different ways to see that result 7. You can see here 1 and 6, of course, 2 and 5, you can see 3 and 4, and other examples. So let's now build the histogram for this and see how these outcomes as probabilities show visually on a graph. So I'm just going to unhide this, and there we go. So as I said, number 7, it's right in the middle, and we see a probability of 16.7% of finding that combination, the combination that gives the outcome 7. And then the other outcomes, as you can see on the left side of 7, as well as on the right side of 7, they beautifully and symmetrically go down at the same rate, perfectly at the same rate. So you can see at the bottom here on the x-axis the potential outcomes between 2 and 12. And again, you can only see one combination that gives you the result 2 and one combination that gives the result 12. So therefore, both have a 2.8% probability of occurrence. And then the other outcomes as explained on the table and as visualized here on the graph. So that's it. Next time that you're playing a game, either Monopoly or the Settlers of Catan, you would know that if you're betting or something, or if you're trying to go towards the number that it's potentially the one that occurs most often. You now know that when rolling 2 dice, number 7 it has that higher probability, and then the other ones as follows here on the graph. Does it mean that number 7 necessarily happens more often all the time? No, it doesn't. You can throw the dice 20 times in a row and you can get, although it's kind of not likely, but you could potentially get 20 results 5 or 20 results 8 or 22s and so on and so forth. So they are independent. But having said that, given the probabilities of the combinations of the 2 dice, you can see which combinations or which outcomes are the most likely to happen. That's it for today. A little bit of fun with the probabilities of throwing 2 fair 6-sided dice. I hope you've learned something here today, and I hope to see you next time.